Good afternoon, guys. Welcome to class. I only got 11 of you, just 1/3 of the class. I'll also start from today. I'll try to record the video, and after that, I'm gonna upload to the Canvas. I hope I can help you. So if you don't understand, you can watch the video recording later, okay? So last class, we learned about two things, right? What consumer wants, which is the preference, and what they can afford, and also which is the budget constraint. We started with three basic assumptions, right? The first one, completeness. Second one, transitivity. The third one, more is better. Then we learned about indifference curves, which is IC, and MRS. So MRS means the marginal rate of substitution, okay? How many units of Y you are willing to give up to get one more unit of X? MRS falls as you move right along the IC, which means diminishing MRS. We also covered three specific IC. The first one, perfect substitutes. The second one, perfect complements and also beds. Finally, we discussed ordinal and cardinal utility, okay? A little bit about budget constraints. So let's continue. Let's work together for equation 3.2. So let's see the figure, the line the line AG, which passes through points B, D, E, is the budget line, right? Is the budget line for two goods, food and clothing. And the slope of the budget line measured between point B and D is negative. The price of food over price of clothing, which is the price ratio. So my question is, how to calculate slope in general? Do you remember how to calculate slope? Slope equal the change in Y over the change in X, right? So basically, if you get the points of X and Y, you use Y2 minus Y1 over X2 minus X1, right? The numerator is the change in Y. The denominator is the change in X. So let's see the graph. So in this graph, we're going to pick 2 points, B and D. The point B is, the coordinates is 20, 30, and D is 40, 20. So we can calculate the slope equal what? 20 minus 30, okay? It's here, Y2 minus Y1, okay? 20 minus 30 over 40 minus 20, which is negative 1/2, okay? It's here. Next one, I want to ask you guys, how can we get the equation like this? How can we get the equation 3.2? How to derive it? So here we have let's work together. We know that the budget line in the general form looks like right? This is the general form, price of food times food plus price of clothing times clothing equals the income that you have. So now our goal is to derive 3.2. So here we're gonna isolate C. Isolate C, so keep PC times C on the left side equals income minus price of food times food. And then we divide it by everything by PC, right? Because we want to isolate. So next one, C equal I over PC minus PF over PC times F, okay? This is equation 3.2. It's just the budget line solved for C, like Y equal B plus MX, okay? So let's see the part of the equation. What is I over PC? It's the y-intercept, right? It's the y-intercept. That means max clothing if food equals 0. That means we spent our income all on clothing, right? Food equals 0. In our example here, see the line? Equal what? I over PC equal 40, right? Which is the total income, 80 over 2 equal 40. Next one, negative PF over PC. What is this? What does it mean? This is the slope, right? In general, this is the slope. This is the intercept. Okay, let me use so this is the slope, which means trade-off rate. In our example, what is the slope? What is the trade rate? It's negative 1/2, right? It's here. We also have F. We also have F here. What is F? It's the units of food purchased, right? So here, F is the variable. Equation 3.2 is just 3.1 rearranged. Remember what is equation 3.1? Just the general form of budget line. Okay, so let's move on. Let's see the effect of changes in income and price. Let's start with the change in income first. So if income increased, what will happen to budget line? If income increased. So originally we are here, L1, okay? Originally we are L1. If income increased, what will happen? The outwards. So the budget line will move outwards, okay? So I use I represent income. If I increased, budget line shifts what? Outwards. Just like the graph shows you from L1 to L2, right? L1, the income is 80. L2, the income is 160. Another case, if income falls, budget line shift what? Inwards, right? Like from L1 to L3, your income cuts half, okay, from 80 to 40. Please bear in mind, if income changes, the budget line gonna shift parallel, okay? Shift parallel to the right or left. So here is about change in income. Next one, we're gonna talk about change in price. Okay, so here is about change in price. Price changes, okay? Here we assume that the price of the clothing is fixed, okay? That's why we have 40 here. Okay, we don't change the price of the clothing, but we're gonna change the price of food, and let's see what will happen to the budget line. So if price of food falls, okay, decreases, that means with your income, you can buy more food, right? Because the price of food decreases, that means you can buy more food. So the budget line what will happen to the budget line? The budget line gonna rotate outwards, okay? Here, from L1 to L, sorry, from L1 to L2. rotates, okay, rotates. Another case, if price of food increases, that means with your income, you can buy less food. So the budget line rotates inwards, right? In the example here, it's from L1 to L3. But here we hold income and price of clothing are the same, okay? We only change the price of food. Okay, if the income changes, the budget line gonna shift, okay, outwards or inwards, but parallel. But if one price of food changes, so the budget line gonna rotate, okay, rotate outwards or inwards. Do you know how to change the night mode in my iPad? Do you have any idea? Because actually I said I closed the automatic one, but I don't know, it still happens like this. But can you see it clearly? Okay, so let's continue. So we talked about the indifference curve and the budget line. Next, we're gonna talk about what will consumer choose, okay? So bear in mind, the maximizing market basket must satisfy two conditions, okay? It must be located on the budget line. It must give the consumer the most preferred combinations of goods and services. That means if you draw the indifference curve and budget line, it will look like this. We have two goods, X and Y. We have budget line, suppose here. Okay, this is budget line. And indifference curve, so the maximizing point should be the indifference curve tangent to the budget line, right? So the pink one is our indifference curve, which tangent to the budget line. So this is our optimal bundle, okay, optimal basket. On the budget line means you spend all your income, right? You don't waste money. On the highest possible IC means you maximize your satisfaction, you maximize your happiness, okay? This is the highest level that you can reach. Let's take a look at this graph. Okay, actually, I already showed you. Let's see, our budget line is here, the blue line. And we have three indifference curve, U3, U2, and U1. Which one is the optimal? Which one is the optimal? It's happened here, right? When the indifference curve U2 are tangent Okay, when the budget line and the indifference curve, they tangent. It happens at point A. And we have the optimal consumption, 40 for food, 20 for clothing. Let's compare the 3 points, okay? We have A, point B, and point D. A is the optimal, and so that means B and D is not optimal. So why B and D is not optimal? A is on which I see U2. How about point B? Point B is here. It's on U1, right? The less utility. How about point D? Point D is at U3, the highest one, but unaffordable, okay? Because we have budget line here. So for point A, that means BC, budget line tangent to IC, budget line tangent to indifference curve. But for point B, it locates at U1, that means lower satisfaction. For point D, it's unaffordable. So the optimal consumption bundle is at point A, right? And at point A, the MRS between the two goods equals the price ratio. Okay, this is very important condition. MRS equals the price ratio. We're going to use this condition to find out our optimal bundles later. Okay, let's move on. As I showed you before, okay, at the optimal point, what you gain equal what you pay. So we have marginal benefit and the marginal cost, but marginal benefit means the benefit from the consumption of one additional unit of a good, which represented by MRS. And the marginal cost is the cost of one additional unit of a good, which represented by the price ratio. So at the optimal or satisfaction is maximized when MRS equals the price ratio. Graphically, the budget line tangent to the indifference curve. For your reading only, for the example, let's see the corner solution. What is corner solution? So I just told you that if budget line tangent to the indifference curve, we're gonna have the optimal consumption bundle. But in some cases, we're gonna have the corner solution. That means the budget line touch the indifference curve at the corner, okay? So that means you only buy one type of goods, okay? Here, you only buy the ice cream. For the frozen yogurt, it's 0. For corner solution, the MRS and the price of ice cream, the price ratio, what is their relationship? So at the optimal, MRS equals the price ratio, right? But here is corner solution, which means MRS, which one is higher, MRS or the price ratio? Any idea? Basically, MRS is the slope of the indifference curve, right? So let's say you want here, you say you want slope is here. But the price ratio is the slope for the bottom line. So one is here, one is here. Which one is greater? Which one is big? For the IC, right? So that means MRS is larger than the price ratio. This is the slope of the IC, which is MRS. This is the slope of the bottom line, which is the price ratio. So in this case, for corner solution, MRS is higher. Let's compare the normal solution and corner solution. We have a normal solution. We also call it interior. That means the optimal bundle happens in the middle of the curve. But another one is corner solution. So the optimal point for the normal solution is the middle of budget line. I don't mean it's strictly on the middle, okay? It's just somewhere along the curve, but not at the corner. So middle of the budget line. For corner solution, it's the end of the budget line. And what kind of condition we need? So for normal, we need MRS equals the price ratio. But at the corner, what I just showed you, MRS, which is greater than the price ratio. Did you buy both of goods? For normal solution, yes, right? You buy both of them. But for corner solution, no, you only buy one. Does IC tangent to budget line? For normal solution, of course, yes. But for corner, no. Just touches at corner. So here is the difference between normal solution and corner solution. Corner solution, which also means that you love one good so much that the best you can do is spend everything on it. Okay, you only buy one good, so the tangency condition never gets a chance to hold. Next part, 3.4, reviewed preference. Here, I'm not gonna go it deeply. The core idea is that we don't ask you what you like, okay? We watch what you choose because action said louder than words. So in this graph, suppose if you can afford both A and B, but you pick A, what does it mean? You must prefer A over B, okay? Because you choose A. Your choice reveals your preference. So here in the budget line I1, you choose A, but you could afford B. You could afford A and B, but you choose A. That means A is preferred to B. Okay? If in the budget line I2, if you choose B, but you also could afford D, what does it mean? That means you prefer B to D. This is just mean reviewed preference, okay? So here, A preferred to B, preferred to D, because you choose A. Let's continue. So here we had more information. Okay, we have two more budget lines, I3 and I4. So in I3, you choose E, but you also could afford A. Okay, you can afford E and A, but you choose E. That means E is preferred to A. And also in budget line I4, you choose G, but you could also afford A. That means G preferred to A. The green, so for the green area, which one is better? For green area, which one is better? For green area, which basket bundle is the optimal? A, right? So for green area, A is better than this basket. How about the pink area? The pink one. For pink area, those baskets that E and G, they are better than A, right? Okay, here is the general idea of this part, reviewed preference. It means you review your true preferences every time you choose. So economists just watch and conclude. We don't ask you, okay? We just see your action. And let's move on. 3.5, marginal utility and consumer choice. So what is marginal utility? It's the additional satisfaction you obtained from consuming one additional unit of good, okay? Like when you eat cow soy, okay? Extra bowl still makes you happier, but less and less so. This is diminishing marginal utility, which means as more of a good is consumed, the consumption of additional amounts will yield smaller additional to utility, okay? This is called diminishing marginal utility. How we get marginal utility? Marginal utility means we take derivative from the utility function respect to the quantity, right? There's one more extra. This equation also means marginal utility equals the change in utility divided by the change in quantity. Okay, so let's please take a look at those equations. We're gonna derive it together, okay? We're gonna derive MRS from MU. What does this mean, the first one? 0 equal M marginal utility of food times delta F plus MUC times delta C. What does it mean? It means you are on an indifference curve, so utility is constant. If you get some food, which is, let's say, delta F, and lost some clothing, which is delta C, the total utility change equal what? You gain something and you lost something. The total utility change equals 0, right? The total utility doesn't change. So that means that's why it equals 0 here, okay? Okay, let's derive it together. So basically we have if you are on indifference curve, you get something and then you lost something. So suppose because we are on one indifference curve, so the utility is constant, right? And suppose you gain some food, but you lost some clothing. So this means the total utility changes equal 0. That's why we have MU marginal utility from food times the change in food plus MUC, the marginal utility from clothing times delta C equals 0 because we are on one IC curve. And then we rearrange it. We're gonna have negative delta C over delta F equals marginal utility from food over marginal utility from C. What is this? The left side. Sorry, what is this? MUF over MUC. It's the definition of MRS, right? If you want one more extra of clothing, how many units of food you have to sacrifice, you have to give up. Okay, so here is MRS. At the optimal, what do we have at the optimal? MRS equal the price ratio, right? So this is exactly from the slide 3.5, equation 3.5, and here is 3.6. Let me go back a little bit, okay? So you see here, 3.5 is the MRS equal MUF over MUC, and 3.6 is the MRS equals price ratio, okay? So it's same here. And now we're gonna combine them. So we're gonna combine those two equations. Which means MUF over MUC, okay? The marginal utility ratio, which is MRS, equal what? Equals the price ratio. And then if we rearrange it, like we divided both sides, we're gonna have MUF over PF. So the marginal utility from food over the price of food equal MUC over PC. Do you know how to get this? Okay, let me show you. From here, we cross multiply, right? Cross multiply MUF times PC equals MUC times PF, okay? This is just cross multiply. And then we divided both sides by PF first. So MUF times PC. Okay, so we divided by PF. And for the right side, it's gonna be MUC alone, right? And then we divided both sides by PC. So we get MUF over PF. Because PC canceled out, okay? Equals MUC over PC, okay? This is how we get it. Next one. What does mean here? Check the slide. Equal marginal principle. Principle that utility is maximized when the consumer has equalized the marginal utility per dollar of expenditure across all goods. What does it mean? Okay, so let's see. Next point. the equal marginal principle. What does it mean? It means MUF over price of food equal MUC over the price of the clothing. Or in general, it means MU, the marginal utility you get from any good over its price it means that you maximize utility when the last baht spent on every good gives you the same extra happiness, okay? Okay, gives you the same extra happiness, which is the utility, marginal utility we're talking about. Let's see the full logic chain. We have MRS. What is MRS? Okay, marginal rate of substitution. It's your taste. Equals what? Equals the marginal utility from one food over marginal utility from consuming additional clothing. Okay, so here is from the utility. Also equals what? Equals the price ratio. Price of food over price of clothing. The price ratio comes from what? Comes from the market. And then we can have the equal marginal principle, which is marginal utility of food over the price of food equal marginal utility of clothes over the price of clothes, okay? So here is the equal marginal principle. Okay, here is the full logic chain. Just pay a little attention on the symbol, okay, here, because we have food and clothing. That's why here is MUF over MUC. But in general, if we talk about goods X and Y, in general, MRS equal the marginal utility from consuming additional X over the marginal utility from consuming additional Y, okay? Here is the general form. You guys gonna use this formula a lot, so please bear in mind. MRS is the ratio of marginal utility of horizontal divided by vertical goods, right? So let me draw this one. Basically, on the x-axis, on the vertical axis, we have what? Sorry, here is horizontal. We have x, right? This is horizontal, we have x. And on the vertical axis, we have y. So you have to be careful. MRS is the horizontal divided by the vertical goods. Okay, MUX over MUY. Clear about this chain? Okay, let's continue. For the example, okay, just for your information, if you can read by yourself after the class. So now let's talk about two approaches that we study consumer behavior. The first one is from graphical approach, okay, indifference preference model, which means budget line tangent to the indifference curve. This is what we've learned above, okay, what we've learned so far, right? So this one we call it graphical approach. Next one is from calculus, from mathematics point of view, utility maximization model, okay? So let's see, what is it? Because here we want to maximize the utility. So basically, you're gonna be given price of X, price of Y, and also M means income, okay? Sometimes I use I to represent, sometimes I use M, okay? But they means the same, okay? Just your income. So you're gonna be given PX, PY, and income. Find X and Y that maximize your utility, okay? Our objective function, what is objective? We want to maximize, right? Our object is maximize. That's why we call it utility function, which is U given XY. U is a function of X and Y. And we want to find the choice, which is X and Y, maximize our utility. In general, we can express like this. We want to maximize, we want to find X and Y in order to maximize our utility function. But subject to, right, we have constraint, right? This is the constraint. Subject to your budget line. This is your budget line. Okay, price times X plus price of Y times Y equals M. M here means income. So if we write in this way, how can we solve it? Have you learned about the method to solve this kind of optimization? So basically, in microeconomics, we want to optimize. For consumer, we want to optimize the utility. For producer, we want to minimize the cost, right? So it's about optimization. So we're gonna use the math tool. And here, because we have constraint budget line, which is a constraint optimization, we need Lagrangian multiplier methods. Have you heard about this one? You must learn it from mathematics, right? Have you learned about this? Yes, okay, which is good. So here, I just help you recall it. What is the step? First one, you need to write down the Lagrangian equation. And then you take the first order condition, which is FOC in short. And then we solve the system of FOC to get the optimal consumption bundles. And then we're gonna check the second order conditions. Sounds easy, right? Okay, so And don't forget the condition, the utility maximized condition, which is the price ratio equals the MRS, okay? The price ratio equals the marginal utility of X over marginal utility of Y. And if we calculate, if we optimize, we're gonna get the results of the utility maximized problem. We're gonna get X as a function of Px, Py, and M. Why? Because Px, Py, and M, normally it's given, okay? It's given by the market. So X star is the demand for X. It's a function of Px, Py, and M. And then we're gonna have Y star. This is the demand for Y. So Y is a function of Px, Py, and M. We have the maximized utility U star. You just plug number of X star and Y star, you will have U star here. Because those things are given. You're gonna be given those things, okay? That's why it's a function of those given things. Okay, let's see the example here. Maximize, so the utility function equals X power half times Y power half, and subject to price of X times X plus price of Y times Y equals your income. So the question is, find MRS, XY, and find the demand functions for X and Y. And also, suppose Px equal 1, Py equal 2, and income is 100. Find the optimal consumption bundles. How many units of X and Y will the consumer consume? Next one, find the marginal level of utility. What is the maximum level of utility and also the marginal utility of income? How do we solve this question? Do you have any idea? Okay, let's. Okay, what we have. What is the step one? Remember, we need to write down the Lagrangian. Write down the Lagrangian. Lagrangian equal X power half, Y power half plus lambda times M minus price of X times X minus price of Y times Y. What is lambda? Lambda is the Lagrangian multiplier, okay? We will see what it means at the end. From now, just treat it as unknown numbers like X and Y, okay? So let's read this equation. The first part, what is this? This is our objective function, right? We want to maximize, okay? Let me go back. Okay, so let me write it down here. So here is our objective function. And here is our constraint. So please bear in mind, every time when you write down the Lagrangian equation of please, the first part is what we want to maximize, okay? So here is the objective function. And the second part, it's the budget constraint, right? Okay, so here is very important. Objective function first, and then plus budget constraint. How we get the budget constraint like this? You just rearrange, okay? Rearrange here. Okay, so let's move each part to the right. What we have, m minus px times x minus py times y equals 0. This exactly the same here, right? And then you use it times lambda, okay? Next step, first order conditions. What does it mean? So we're gonna find the first order condition for each variable, okay? So here we have three variables, x, y, and lambda. They are variables, okay? This is the variable that we want to find. It's unknown. So first, we take the partial derivative with respect to x, curl L over curl x, and then we set it equals 0. What is the curl x over curl L over curl x? What is this? So it's like we take derivative from this Lagrangian equation, right? So here means you know how to take derivative for a power function, right? So suppose xn, and then we want to take derivative. That's gonna be nx power n minus 1, right? Okay, so now please apply this to x. So let's work together. 0.5 x power what? 0.5 minus 1. So that's going to be negative 0.5, right? And then we treat y as constant. So y is the same. Minus. So see here, it's negative px, right? And then we have lambda here. So it's going to be negative lambda px. We set it equals 0. And then let's represent it as lambda. So from here, we can get lambda equal 0.5 x power negative 0.5 y 0.5 over px, right? Here's our first equation that we're gonna use it to solve. How about first order for y? So curl L over curl y equals 0. Okay, so I give you 4 minutes. Please find the first order for y. That means you take derivative respect to y only. You treat x as constant, okay? I'll give you 4 minutes. Please try. It somehow looks like the same, right? Okay, so here, 0.5. And then you treat x as constant, so x power 0.5. But here y gonna be negative 0.5, okay? Because, okay, here we have x power 0.5. So if we take the derivative, it's gonna be 0.5 x power 0.5 minus 1, which is 0.5 x power negative 0.5, okay? The same logic. So you apply this power rule to y, you will get this 0.5 x power 0.5, y power negative 0.5, and then minus. For y, we have minus py, right? And also lambda. So here is minus lambda py equals 0. And then here we rearrange, we'll get lambda equal half x power half y power negative half over py. Okay, this is gonna be our second equation that we use to solve. Next one, FOC for lambda. So here basically just what? This one, okay? The coefficient of lambda. So we have m minus px times x minus py times y equals 0. So here also means that pxx plus pyy equal m. So here gonna be the third equation. And next step, we're gonna solve the system. Solve the system. So let me give you a hint. So you need to set equation 1 equal equation 2. Because equation 1 and equation 2, both of them equal lambda, okay? So you set them equal. And then you can solve. And then you will get y equal, y is a function. You will get y. Okay, due to the time here gonna be your homework. I'm gonna post on Canvas, all right? So now I helped you maybe just a little bit. So next one, just solve the equation. So your final answer gonna be x star equal what? Y star equal what, okay? And then you plug x star, y star, you will get utility. Maximize the utility, okay? So here gonna be your first homework. I'll post on Canvas. And do you have any question before I stop the class? Yes? For this homework, let's say before we start the class Thursday. Okay, so Thursday is the teacher's day, but it's not a holiday. And also the faculty only have the activity in the morning session. So I'll see you guys as usual, okay? Do this homework and we're gonna discuss it together. Okay, so thanks for coming and I'll see you on Thursday, okay?